Hi. So I've been working a little bit on the geometry stuff again recently, and I don't really know where to start, I guess, but I'll try to keep it simple. I'll start with just opening up the shape editor. I refined it a little bit. I can use my mouse wheel to zoom in and out now and stuff. I'll just really quickly whip up a shape, I guess. There we go. And then I added in a thing that generates a signed distance field, and then I got another button that deletes everything so that we just have the signed distance field. And then I added in I think it's called the marching squares algorithm, because in this case we're in 2 dimensions. If it were 3 dimensions, it would be marching cubes, but it's essentially the same algorithm. And that can take this signed distance field and approximate a shape. Once we get rid of the signed distance field, you can see that it's actually really close to the original shape that I made. It's got some problems, but it's still pretty stinking close. There were some other things I did. I added in a thing where I made another bunny shape. I'm gonna load that in. Okay, so I added in a thing where it'll do all of those steps that we just saw, but it'll just do it all in one go with another button, so I can go bam. This is the approximated version, and oh, it's really slow. Okay, let's try something a little less detailed. There we go. Now, what's fun about this is that I can just keep doing it over and over and over and over and over and over and over, and you can see that with each iteration, it actually gets. There's some. You could say that there's some signal degradation, so to speak. I took it even further. Added in a button that makes it go inset 1 unit, or I can go outset 1 unit, so I can make it fun, like fatter, so to speak. Let's do like a Rayman. There we go. It's a Rayman bunny. And now we have a potato instead of a bunny. Back to the bunny. I did another one which generates a line on the outside and on the inside, as well as doing a threshold at the original depth. So we get this, but right now I'm using a naive algorithm for determining if we're on the inside or the outside, and that has some really weird side effects. Actually, I'm gonna go back to, no, I do want that. So, for instance, if I were to create just a really simple square and generate the signed distance field and get rid of those, you'd see it looks fine. Do it again, but this time I'm going to leave a gap. So you can see now that there's this problem here. And this does have an effect. I bring the bunny back. Actually, this would be a really good opportunity for me to show the other feature that I added in. I've got this preview, and it runs surprisingly fast. The marching squares or marching cubes algorithm is shockingly quick, thanks to the fact that it has lookup tables. And you only have to generate the signed distance field once, thankfully. And once it's generated, you can just do this, and it's shockingly fast. But yeah, this is like a granular. Like, you get to choose the exact threshold point, the ISO value, as it's sometimes called, or ICO value. I don't know. It depends. Anyway. So if I were to create a gap here and then do this again, you can see the effect it has. It's not quite what I expected to happen, actually. Just an interesting side effect of the naive test, the naive inside-outside test. So if I instead did something like this, you can see that it still thinks that a good portion of this is on the inside, but the distance values here are a little funny. So we end up with these really odd-looking angles here. And I actually know why that's happening, but it's still kind of neat. So if we go back to using this, the preview, it looks fine at some distances, kinda, up until we get to like right there. I think it's neat. So my air quotes robust solution still needs some work. If I'm going to be using the marching squares algorithm, I'm going to have to make this work a little better than this. I'll probably have to make... I'll probably have to run another iteration for determining... to generate a signed distance field from this signed distance field. Yeah. Oh, last thing. I'm going to just load in a square. Let's do a kaleidoscope. So F8 does that thing where it shows the approximation and then another approximation at a threshold of 0.5 and then a threshold of negative 0.5. I think this one's the negative 0.5 and this one's the 0.5. But if I do it again, and again, and again, and again, and again, this is running a bit slower than I was expecting it to be. I think... Let's try this instead. Whoops. No. There we go. It's like a kaleidoscope. And the weird thing is that even though everything started out symmetrical, if we keep going, things start becoming asymmetrical. And I'm not entirely sure why. I mean, I have a few theories. All I know is that this looks super neat. They're like Rorschach tests almost. Okay, there we go. Now we're getting some really good examples of where the symmetry starts breaking down. Like right there, not the same. Right there, not the same. I'm just gonna hit this a few times. See what we get. One more thing. Let's do let's just load in a shape and start expanding. We're using the naive test right now, so whoops, that's not the right one. There we go. Just keep going bigger. And as holes start appearing, things start going a little wonky. It's neat. All right. Thanks for watching.